Hello, my name is Shain Goswami, and in this video I'm going to demonstrate one of my tool which I created for Disney. And here on this side there is a tool called as RenderTool, and this tool is a complete pipeline for making game ready asset, which includes the customized rendering of the assets and version control them, optimizing them, and sending them to the game server. So we would see all the options of this tool, and I would just quickly show you all the working with the example. So we have the scene open in Maya, and it's a huge scene which has almost like 1,000 meshes or group of meshes. So when the scene is loaded, you can press reload UI and it would fill the UI of this tool with the information in the scene. So here we see all the different parallax layers, and as you select a different layer, it would select all the objects existing inside the layer. So you would not have to press any enter and do anything extra to select those objects. You just can keep scrolling through the list of all the parallax layers. So if I select parallax layer 2 and I want to render it, and because this tool also version control all the files, so for showing this example, I would uncheck check-in button, which would not check in the rendered file, and then I can press render selected layers. So it has rendered parallax layer 2 for us. It does some pre-calculation before rendering a particular layer. It applies certain shaders if required. It also turns off the visibility of all the parallax layers existing in the scene so that it can just render that particular layer. And all preview on and all preview off are the options for bringing in the concept art. So each parallax layer is based on a concept art, and we bring that in the scene using this tool, so an artist would not have to do or bring them manually. So I would not be able to show you the concept art because it's still an unannounced game. So next feature is reference and dereference file. You can click on any parallax layer, you can press reference, it would save the file as a reference outside the scene based on the name of the parallax layer and bring it in again in the scene. So your scene would look like it's untouched, but this would create a reference file and someone else can work on that reference file simultaneously. So the next step is rendering the objects. So the complete game is divided into two type of objects, which are interactive and non-interactive. All the non-interactive objects go inside the parallax layers, and interactive objects comes inside the object list. So for example, this cactus is an interactive object which can be interacted by the player of the game, and this rendering, I call it a customized rendering because it's a smart rendering. And what it does is, first you define the plane of the scene and you press set as ground. So now the scene knows, or the tool knows, that this is the ground plane, and you select any of the object and it would render, or it would create an image of just that part which is above the ground. And what it also does, that if one object is intersecting another object, it would crop out that part too. So it's a customized rendering, and when we render this object, it doesn't render the whole scene, it would just render that particular bounding box of the object, because we have set a algorithm for converting the 3D space to 2D space. So it would find out the 2D space in the render view and start rendering only that region. So it's a customized and the smart rendering, and I would show you the example of that. Before that, I would uncheck the check-in box because I don't want to check in the image. So I would press render selected objects. So now it has finished rendering the object, and if you would go to the scene file to see this we would find that the bottom part of this would be cropped so that artists would not have to manually crop the image. So here is the image, and it has cropped the bottom part. So all that calculation is done using the Python image library, which is also called as PIL, and it multiplies the alpha channel, and that's how we get the cropped image. So the next part is setting the height mesh. Height mesh is used to define the 3D plane because the game is going to be a hybrid game. Most of the objects are 2D and there are only a couple of things that are 3D in the game, and height mesh is one of the 3D mesh which defines the avatar where he can walk. And so if you want to create a height mesh based on certain meshes, for example, if I want to include this rock, I would add selected mesh. If I would want to include this plane, I would add that selected, and I would also include some from here. So I have selected this mesh as well. So what exactly it does is it uses Maya API, and it recasts and over the meshes, and it wherever it hits the point, it creates a vertex. So that's how we create the height mesh. So let's see an example of generating the height mesh, and I would uncheck any check-in of the XML. So I would say update or generate height map data. So it has now generated the height mesh, and if you would just go to view selected, this mesh would have all the height information based on those 3 objects which we selected, and this would define the ground in the game. So that's how we create the height mesh, and then this complete information can be exported in the form of XML by using update height map data. So there are some restrictions which are required by the game engine. If your camera is within this plane, it would not be able to export it. So I would modify the height map real quick, and I would export it, and I will show you how the XML information is written in an XML file. So what I have done is I have removed some of the faces of this mesh which were right under the camera. That is not allowed by our game. So now I would try generating the height map data, and it's all set. And now we would go to the XML file and see what type of data it has generated. So I have opened that XML file in which all the data is written, and here is all the information. So it has the row column information, and this number is the height in the y-axis of that particular vertex. So that's how the data of the height mesh goes inside the game. So the bottom tool is used to paint the faces of the height mesh, and there are different tiles here by which artist can paint this height mesh, and those tile IDs will also go in the XML file, which would define which path is walkable, which path is not walkable, and which path is water or anything else. So that's all. These all buttons are for painting the tile IDs. The next section is to send the render to the render farm. If any render is taking so long, that can be sent directly from this tool to the render farm. And the render farm is also developed or written by me, so I know how this tool can communicate to the render farm. So these checkboxes are the optimization and the version control. Usually they are always checked because we want our artists to version control each and every file and optimize each and every file, but just if they are testing anything, they can uncheck these boxes. And what optimize does is, if you export anything or the art asset to the game server. It checks the file, it breaks it down into small pieces, it removes that part of the image which doesn't have any pixel. So if there are two circles, one on the top right, one on the bottom left, and this there is a whole big image that needs to be exported, what this tool will do is it would crop the images, it would separate out these two circles, it would embed the information of the cropped image into XML file, and it would export it for the game. So I would show you the example of one image which is cropped and broken down into the pieces, and all this calculation is also done by Python image library. And these are all the images, and they are broken down into small square pieces, and we are using the square pieces because eventually it would go into a sprite sheet, and for the optimization purposes we want to keep the size of all the blocks or all the images same for a particular sprite sheet. So complete render has been broken down, extra pixels have been removed, and they are ready to be imported by the game server. So that was the quick overview of the render tool which I created for Disney, and that's it. Thank you.